So next, we're gonna talk about the JK flip-flop. So the JK flip-flop is very similar to the SR, but only difference is that in this case we don't have the invalid state. In case of the S and K, you remember we have the invalid state. But in this case, with the JK flip-flop, we don't have the invalid state. Instead of the invalid state, here the 1-1 case, so this is the last case, what's happening is the output is toggling. So meaning that if the output was 1-0, after this input, it becomes a 0-1. Okay, so that is the only difference between the SK and the SR and JK flip-flops. Okay, so what's happening is that, so let's see, we have actually the circuit for the JK flip-flop. Flip-flops. This is the JK flip-flop. Yes, this is J, this is K. Okay, so pay attention here. So input is 1, 0, right? So the input is the 1, the J is 1, the K is 0. So output is also the 1 and 0. Now, if I change the output to be the 1, 1, okay, suddenly you can see the output is toggling, right? Keeps changing from one state to another, from one state to another, okay? So this is the only difference between the SR and the JK flip-flops, okay? So output is now toggling. Okay, and then these other, we said that D and JK flip-flop are the synchronous. They are synchronized to the clock. So this is the clock coming in. So the output is synchronized to the clock. But also we can, add the extra inputs, right? So these are the inputs. They can actually reset or change the condition of the output. Okay, change the value of the flip-flop or the latch. So let's see how it works. So we have the two input. This is the preset and the clear. Okay. So let me connect this circuit. We can see how it works. So now here you can see the JK flip-flop. We have now the reset button here. So I attach the reset button. Okay. So again, what's happening is that, for example, this is a D flip-flop. It doesn't matter if you have D flip-flop or JK flip-flop. Usually what you can do is you can add the manufacturers, they add the two extra buttons for the preset and clear. So for preset, when you click, it will change the output. So with preset, for example, if you preset it to the 1, when you click the preset button or you send the high signal, there's no button actually, you send the high signal through the preset input, the output will change to the 1. Same with clear, when you send the 0 through the clear, the output will change to 0. Okay. So in this case, it will not depend on the clock input. So it will be asynchronous, not synchronous. Okay, so you can change the output whenever you want. Just sending the signals through these two inputs. So let's for example, here we have the input J and K, right? So as you can see, the J is 1, the Q is here. So this is the Q. Let me label this. So this is the Q, and this is the Q complement. Okay. So now if I change to 0 and 1, as you can see, the output is also changing 0 to 1. Okay, now what I can do is here I have the reset button. Okay, so when I click the preset button, I click, as you can see, when I click, output is changing. So original output is 0, 1. When I click, as you can see, output is now changing to the 1, 0. So if I release, it goes back to 0 and 1. So this is how it works. In this case, in case of the circuit works, they don't have the separate preset or clear input. Or they use a different approach. What you can do is you can actually just change the preset value. So instead of the 1, I can change it to the 0. For example, let's change the output. So J is 1, K is 0. Output is 1, 0 as well. So let's say instead of the 0, I want to change the preset value to 0. So now whenever I click the preset button, so let me change the button label. So this is the preset. Okay. So when I click the preset button, pay attention to the Q becomes 0. So I click and Q is 0. I release, it goes back to 1. Okay. And this will happen regardless the clock. Okay. So this input is not synchronized to the clock. Okay. So that's why it's called the asynchronous. Okay, and this is how you can implement. You just add the extra inputs to here, as you can see, we have the extra input as a NOR gate, right? So this is extra input for the clear, and this is extra input for the preset. Okay, And this is the how the waveform. So let's say, for example, at the beginning the clear is high, right? So this is a preset. So the preset, so meaning the output will follow the preset value, right? So now in this case, for example, if the preset is 0, so the 0 complement becomes 1, so output is 1 here, right? So throughout this duration, output is 1. It's following the preset. But when the preset is released, so in this case they use the negative logic. So meaning that when they press the button or release the button, okay, so now it will follow the input D. So if D is, for example, in this case D is 0, so output is 0. In this case D is 1, so output is 1. In this case the D is 0, so output is 0, etc. Okay, when you click the clear button, now it follow the clear here, right? So regardless the clock, so output will be always equal to 0. So it will ignore the clock. So this is how it works. Okay, you can just create the dual positive edge trigger D flip-flop, etc. You can combine the multiple flip-flops and get a bigger storage.